Welcome back guys, this is CC Notes and I am back with a new video. So today's topic is merge sort. Merge sort is actually a divide and conquer algorithm where we divide the array into two parts into using the middle position and make it a smaller problem and solve. So before going to this algorithm, we want to revise something about the divide and conquer algorithm. Once we can understand the basic concept of divide and conquer algorithm, the merge sort algorithm will be easier for us. So firstly, what is divide and conquer algorithm? So divide and conquer algorithm can be defined as a top-down algorithm design technique based on multi-branch recursion. That means we will do some recursion technique in multiple branch. So this is actually a top down algorithm design technique. Here we have to take the help of recursion using the multiple branch that can be defined as the divide conquer algorithm. So basically in three steps we can explain the divide and conquer algorithm. In the first step we have to recursively break down the problem into two or more subproblems of same or related type until these subproblems becomes simple enough to be solved directly. That means in the first step we have to break down the problem into two or more subproblems of same or related type until this subproblem becomes simple enough to be solved directly. Then in the second step we have to solve the subproblem recursively. That means using the recursion we have to solve the subproblems, and this solution will be successively and independently. That means we have to solve the subproblems independently and successively. And in the third step we have to combine these solutions. We have which solutions we have, that means which subproblem we have solved before recursively. We have to combine these solution to the subproblems to create a solution in the original problem in some order. So in these three steps, using these three steps, we have to implement a divide and conquer algorithm such as merge sort. So example here, binary search, merge sort and quick sort. So by merge sort is also a divide and conquer algorithm in the use of divide and conquer algorithm. So we are going to the algorithm of merge sort. Firstly, we are taking a input and we are taking a array a low comma high as input. The in lower index will be the low and higher index will be the high. This array will be, we have to sort. So in the first line, if low less than high, then we have to calculate the mid. The mid will be calculated as the floor value of low plus high by 2. In this, using this mid, we have to split the set into subproblem. So firstly here condition is low less than high. That means if there are more than one element, if there are more than if until there are more than one element, the element will be, the element set will be divided into sub part. And if in this one sub part there is one element, then this process will not be worked. So in the first line, until there are if there are more than an element, then we have to calculate the mid as the floor value of low plus high by 2. And using this mid we have to split the set into subproblem. Here actually two subproblem, from low to mid one subproblem, and from mid plus 1 to high. That means we have to implement two subset, from one from low to mid and another from mid plus 1 to high. So using this recursion, that means recursive function, it will break down the array into two subparts in each iteration. Then we have to merge the problems we have divided into or we have split it into the sub problems. So we will use the merge function. Here we will take the input as low, mid and high. To combine the solution, we have to use the merge function. So merge function, the parameters are low, mid and high. In the merge function we can um, say that there will be, in each iteration there will be two subset, one from a low to mid and another from mid plus 1 to high. As using the merge sort, these two merge sort, we have divided the array into two subpart in each iteration. In each recursion call recursive call we have divided into two subpart. So when the merge function will be called, then there will be two subparts, a low comma mid. That means one subpart will be indexed from low to mid, and another index will be mid plus 1 to high. Two subparts will be there, and our goal is to combine these the two sets into a single set residing in a low to high. That means in the real array, we have actual array we have taken as input. So for that we are taking auxiliary array b here as a auxiliary global array. So there will be some control variables to control the indices. So I equals to low, which will control the first subset, and j equals to mid plus 1, which will control the second subset, and k equals to low, which will control the index of the auxiliary we have array we have taken as b. So first, while I less than equals to mid and j less than equals to high, that means we are traversing the two subset. We are traversing the two subset from using I equals to low to mid and j equals to mid plus 1 to high. As the first subset is indexed from low to mid, or we will traverse from low to mid, and as the second subset is indexing from mid plus 1 to high, we will traverse it from mid plus 1 to high. So using these two conditions, we will traverse do if ai less than equals to aj. So currently my I equals to low and j equals to mid plus 1. That means we want to check the element in the first subset is less than the element in the second subset or not. If it is, that means the element in the first subset is less than equals to the element in the second subset. That means the element in the first subset is lesser than the second subset value or element. Then the minimum element, that means the value in the first subset, will be copied into the auxiliary array, which will store the sorted elements. So bk equals to ai. That here, if the condition satisfy, the ai will be minimum and ai will be stored into the auxiliary array. And as it is using the array elements of the first subset, so we have to increase the index of first subset, which will be I equals to I plus 1. And if this condition fails, that means a value in the first subset is not less than the second subset element. That means the value in the second subset is less than the value in the first subset. So then the value in the second subset will be copied from the second subset to my auxiliary array we have taken as b. So we have to take the element as aj, and we have to increase the index of the second subset element as we are taking this element. So we have to pass the second element of the second subset, so we have to increase the index of second subset. So j equals to j plus 1, and this k equals to k plus 1, we have told already that k is controlling the index of the sorted array auxiliary array we have taken as b. So k will increase the and k will increase the index of that means the index of auxiliary array. So using this, while we will compare the values and we will take it at in b, and then we have to take the remaining elements using this if else. That means if somehow I less than equals to mid, this condition fails, that means I has reached to the mid position, but j has not reached to the high position. So we have to copy the second subset elements we have, which are remaining elements. So this condition will be false, because if I has reached to the mid position, I has reached to the mid position, and I will, if I greater than mid, then this condition will be false as it is and if j less than equals to high, this condition remains true, then we have to take the elements, the remaining elements from this second subset to actual my the auxiliary array, or using this to if else we will store the remaining elements. So I greater than mid, that means the value in the second subset we have to take the remaining elements from j to high bk equals to al. That means we are storing the remaining elements from the second subset into b, that means the auxiliary array, and we will um, as we are taking the values, so the k index will be increased. And else case, if this condition fails, that means I greater than mid is not in the case, that means j greater than high, that means the second element all we have taken the first the remaining elements in the first subset we have to take. So using this else we have to take the second the values in the first subset. From the first subset the remaining elements I equals to l equals to I to mid, the remaining element will be copied to b and k index will be increased. So using this algorithm the elements will be copied, the sorted subset and the sorted elements will be copied into the b, that means the auxiliary array we have taken. So we have to take it from b to my actual array a. So using this for loop l equals to low to high, we have to take the elements from b to a, and so al equals to bl, we are assigning this. So using this algorithm the merge sort the sorting of the elements will be done, and this algorithm will be clear if we can visualize this algorithm. So using this uh, image, you can see this image, this is getting divided into sub parts until the elements in the sub parts in is 1, the number of elements is 1. Then we have to check the elements 5 and 6 comparison, 5 is lesser than 6, so 5 6, 3 and 1 comparison, 1 is lesser than 3, so 1 3. Then 8 and 7, 7 is lesser than 8, so 7 come first, then 8, then 2 and 4, 2 comes first, then 4. Then the comparison will be done from using these two subsets, then 1 then 3, then 5, the remaining element 6 will be copied from the first subset to this, then 7 8 and 2 4, then 2, then 4, the remaining element 7 and 8 will be copied from this to. Then the comparison will be done for the two sorted subset, 1 then 2, then 3 and 2 comparison 2, then 3 and 4 comparison 3 comes first, it is lesser than 4, then 5 and 4, the forms 4 comes first, then 5 and 7, 5 comes first, then 6 and 7, 6 comes first, and then 7, then 8, the remaining elements. So using this picture we can visualize the algorithm. Then we will see the code. Using this we have already written the code, we will see that. So using the input function we are taking the input here, a20 is the array and then n is the number of elements. So using input a we are taking the input, a is the argument, a is the array itself, we are taking it as our argument and will pass in the into the input function. In the input function we are taking the input, enter the number of elements, then enter the elements we are taking, and we are returning the value of n so that it can recognize the value of n. So it is actually returning the value as n. Then we are assigning low as 0 and high is n minus 1, as we are taking the input from 0 to n minus 1, as array store the value from 0. So we are taking the input from 0 to n minus 1, so low equals to 0 and high equals to n minus 1, and merge sort will be called using a low high. Here we are taking, actually a is not a global array, it is a local array, so we are passing the array a in the merge sort function, then it will be called, and merge sort in the merge sort function same as the algorithm. So far in the first line we have to split the we have to calculate the mid position, and then merge sort will be called for one for low to mid, that means the first set, and second one for mid plus 1 to high. And using these two merge sort function it will divide the array into two sorted two subparts. Then we have to call the merge function using this a, low, mid and high. A is actually is not a global array here, so it is a local array, so we are actually passing the parameter as a, and then low, mid, high, same as the algorithm. Then it will go to the merge function, So we are assigning the control variables I equals to low, j equals to mid plus 1, and k equals to low. And then the same for the first subset, I less than equals to be mid, and then for the second subset, to control the second subset, j less than equals to high. Then if the same value in the first subset less than the value in the second subset, then we have to copy the first subset value into the auxiliary array. Here we have taking the auxiliary array as p, so p k plus plus equals to I plus plus, because actually in the index part we are actually assigning increasing the value, so so that the code will be minimized, and else case the value from the second subset will be copied into the auxiliary array bp. So using this will be copied in the for the remaining elements, this if and this if will be worked. We have already seen in the algorithm, so no need to explain further. And using this algorithm, this job will be done into the sorted elements will be stored into the p, and then we have to take it from p to actual array ak. So using this for loop, we have to take the elements from p to a, and then the elements will be displayed using this display function, display a comma n, and you have to call the display function, and your sorted array will be I equals to 0 to n the ai values. That means the sorted array will, the sorted elements will be printed. So we have to check the output. We will check the output here. We are checking the output. So suppose here the value we are giving, and the number of elements 8, and then the element the elements, suppose 70, 80, 20, and 10, then 30, 50, 40, and 60. And these are the 8 values, and we are checking the output. Your sorted array 10, 20, 30, 40, 50, 60, 70, and 80. That means the array is actually sorted. So this is all about actually Marshall. That's all for today. So please hit the like button if you like the video, and comment us for any further explanation, and also subscribe us for the latest video tutorials. So that's all for today. Thank you.